In this video we are going to learn matrix factorization using Blueqat. We will be doing this in Google Colab. Like we did in previous video, we will start with installation of Blueqat. We can do it by using this code !pip install Blueqat. Type the code that was shown earlier in Google Colab. Then click on play button and Blueqat will be installed. Matrix factorization is a machine learning algorithm used in recommendation engines. A familiar example of a recommendation engine is the Recommended Products section of a shopping site. From the past purchase history of user A, we can determine other users B who have similar purchasing tendencies. If user B has purchased a product in the past, there is a high possibility that user A will also want it, so the system encourages purchase by displaying it as a recommended product. This time, we will use quantum annealing to perform matrix factorization. We use Movie Lens dataset. It is a dataset of 100,000 ratings, 1 to 5 stars, by 943 users for 1,682 movies. First, load the dataset. The dataset is divided into two parts, one for training and one for test. The contents are as follows. The rating given by the user indicated by user ID to the movie indicated by movie ID is recorded as rating. We construct matrix from the data. The row will be user ID, the column will be movie ID, and each element will be the rating corresponding to that row and column. Here, from the viewpoint of problem size, only data up to 100 for both user ID and movie ID will be extracted, and the matrix will be size of 100 by 100. Matrix F factorization decomposes such a matrix as shown in the figure below. Features represents the features that the user and the movie have respectively. A feature value indicates the preferences and tendencies of a user. For example, the user likes action movies. The same can be said for movie features, such as action movie or not. Formulated in this way, we expect that users who like action movies will give high ratings to action movies they have not yet seen. Matrix factorization finds W, H that satisfy V approximately WH with as much accuracy as possible. In particular, the problem where W is positive and H is restricted to binary, 0 or 1, values is called non-negative binary matrix factorization, NBMF. NBMF repeatedly updates W, H through the following optimization. Furthermore, each column I of H, HI, can be optimized independently as follows. CDOTF denotes the Frobenius norm. Since H was assumed to be binary, we can take advantage of quantum annealing to find Q. Specifically, it results in a linear least squares problem, and the following QBO formulation is known. Let's implement it in Blueqat. The following can be performed with both quantum annealing and QAOA. We will do the learning. When the reduction in errors converges to a certain degree, learning is terminated. Use the learned features of user and movie to predict users' ratings of movies they haven't seen yet. The combination of users and movies to be predicted is included in the test data, and the evaluation in the test data is taken as the correct answer. Let's calculate the average predicted score for each of the test data with ratings of 1, 2, 3, 4, and 5. The average predicted score for each of the test data with ratings of 1, 2, 3, 4, and 5. 2.47, 3.32, 3.52, 3.60, 4.09. Overall, the test data and the prediction results show the same high-low evaluation trends. It seems that it is difficult to discriminate points 2, 3, and 4 with this model and learning setting, but it may be possible to discriminate points 1 and 5. From the above, we have implemented a recommendation algorithm using matrix factorization with quantum annealing, QAOA. That's all for today. Thank you.